Could a form of artificial intelligence simulate the feeling in the voice?
Simulate a what in the voice?
The feeling in the voice.
Like an emotion.
Yeah.
Theoretically, yes. I mean, this is something with, especially voice system. This is really a sort of a topic that's not well understood. Emotional expression and how to detect it and how to sort of copy it. You can do it, and there are sort of mechanisms or computer programs which can, discriminate different emotions by machine. The thing about it is at the time, like for example, you've got programs like Siri or Cortana or different sort of voice synthesizers, like when you're talking to your cell phone and it talks back to you. On one level, there's a group of engineers that work on those, and what they do is they build a lexicon, and then it's that lexicon through different rules, and it has different sounds also stored in it, and when that wants to talk, it can string a bunch of sounds together to make a word, all by rule. I mean, this is all done by a computer program. There are rules that are, sort of govern how the machine does this. One of the big things with this, one of the big problems with this type of thing is that it never goes to market. That product never goes to market without human phoneticians who are there to actually tune those sentences. So what happens is the machine, what it does in the first instance, is just, it puts a bunch of sounds together, but it doesn't give it any sort of intonation, it doesn't give it any sort of like rhythm, it doesn't give it any sort of like what we would consider, human qualities. One of the things, for example, that you notice, like if you talk to Siri, one of the things that makes it sound so robotic or so mechanical is the idea that you can't program them. For example, when we talk, we breathe, right? I just took a breath right now. I mean, it was only about 10 milliseconds that I used. That pause was only about 10 milliseconds. But what it makes it is sort of really variable. Human speech is really variable, right? The intonation goes up or it could go down, depending on the context. We breathe, we take breaths. Sometimes we have to stop to think. None of these things a computer can do, right? Because those are sort of what are called random acts, right? It's what they call stochastic element or stochastic element. Like when I'm breathing, I'm not thinking about breathing. It's a mechanical thing, right? Or when I have to take a pause to think, you can't predict that, right? You can't predict that using mathematics when I'm going to stop in a conversation to think. Maybe if I woke up and I didn't have coffee, I don't think as fast, and I have to take a longer pause or I have to take more pauses. Those are things that can be added to like the synthesized voice, but only by a human. And in fact, that's one of the biggest markets now for people that work in linguistics and phonetics and things like that, is working in those companies to make those more human-like. Now, theoretically, in 20 years, could we get to the point where we don't need those humans? Yeah, you can do it because each time a human has to make a change, the engineers can track that change, and once a change becomes, like if it's a constant thing that the person, phonetician or linguist, has to change, then yeah, you can write a rule for that. And in theory, each time a new rule is written, the machine gets better. And theoretically, yeah, I don't see any reason why it couldn't. We're not there yet, but we can get there easily.
So in a future, emotions could be perceived in an artificial intelligence speech?
Yeah. In fact, we have pretty good models of it already. They're just not 100%. In fact, this is cool. There's a line of research now, not only in speech, but there's a line of research I was just reading about the other day of people who analyze Google searches, and they say that you can actually, by your Google search, they can analyze your emotional. They can have pretty much a 90% chance of getting that right, knowing the emotional status of the person based on how they do their Google searches.
Do you think an artificial lexicon could be developed? A lexicon specifically for artificial intelligence?
Yeah, definitely. I'm not sure if it has been done. Seems like probably, if I had to guess if it's been done, I would say it has. I just don't know. Theoretically, can it be done? Yeah, it can be done. And it probably has been done, but I don't have enough information. But what do you mean, for example, an artificial lexicon? One that the machine recognizes or can produce artificial words?
That the machine can produce artificial words.
Oof. I see problems with the theoretical part of it, but if it's already been invented, I'm going to look stupid. One of the problems would be, I mean, it depends on how much randomness there is you expect it to give. I mean, if you expect it to create new words, I think that's already been done. It would just depend. I mean, they're such complex systems. It would really depend on making that question sort of more precise, because I'm sure that there are artificial lexicons. I know that there are probably systems that can produce artificial words. I'm almost positive about that, but I'm not sure. But yeah, I'm sure one of the things that I've noticed about when I read things with language and artificial intelligence, most of the things that we can think of now, they've been working on for about 20 or 30 years. So I mean, yeah, I'm sure that that's already in the making. Why do you ask, for example, though?
Well, we made this question thinking in the consequences that could have in the language, in human language.
Oh, now that's different though. Because that could in fact have an effect, because of course, I mean, if it gives a new name to something and enough people accept the name, yeah, that could certainly happen.
Not from a more creative point of view, the machine could perceptibly perceive the emotions of a human being language.
Yeah, I mean, this is like going back to your first question. I mean, you can definitely do that, but what do you mean? Do you mean to create? Could you say the question again?
Could a machine perceive the emotions on a human being speaking?
Yeah, that's one of the things that, I mean, it's related to the first question, but that's one of the things that we've got. I mean, we've got it pretty well done. I mean, it can be done. It's just not 100%.
For example, do you think it will be ever possible to fake human voice with artificial intelligence?
Oof. Possible? Yeah. Are we a long way from it? A long, long way. Like I said, machines learn using mathematical models, using different distributions, the distributional statistics of different parameters, acoustic parameters. I know that this sounds too complex, but basically what it does is the machine learns when there's a consistent pattern in one of the acoustic parameters. Like say, for example, the first format. The first format for an A, or an A, or an E, or an I, or an O, or a U, or the second format or the third format. Those are fairly consistent because they belong to the same vowel category. Now, a machine learns that systematicity by the distribution of the statistics. Let's say, so for example, if you feed the machine 100,000 repetitions of an A, it can take all of the systematic information out of that acoustic signal for the first format, the second format, the third format, to reproduce it, in order to reproduce that sound. What happens is machines, and what's really difficult for machines is what they call fuzzy categories. Fuzzy means like ambiguous. So for example, and those fuzzy categories come from sort of the context of the sentence or where the vowel is. You know, we don't always say what distinguishes human speech from a computer speech is that there's huge variation. There's a lot of systematicity in our categories, but there's huge variation that our mind can understand and process, but that's that's not necessarily complementary to how a machine learns, because a machine only learns from statistics, right? So a machine takes all of its information from the systematicity of data, whereas humans know what to do with the variation of that data. So for example, and not necessarily, I mean, I can vary my voice, right? And I often want to. I mean, it's oftentimes desirable to vary your voice, to change how you talk, right? Depending on whom I'm talking to or in what context or what register or whatever. And now technically you can take all of those things and program that variation into a computer, but we're not there yet, and we're a long way from being there. And that's just with vowel categories, for example. Also breathing. When do I take breaths? Well, I take breaths when I need one. And I suppose that you could find some systematicity when I take breaths, right? Or when I pause, or where I have to pause to think, or something like that. But there's a level there of randomness, right? You can't predict when I'm going to take a breath, or you can't predict. That you can probably predict because it's physiological, but you can't predict when I'm going to stop to think, or you can't predict, when I lose my train of thought and I have to switch or something. You know what I mean? So there's so many random variables that have to be controlled for that we're really a long way away.
And do you think that the random, let's say, factor could be included in a machine? I mean, if you program the machine to do random things, would it be like more human-like?
Well, what happens when randomness becomes systematized, it becomes systematic, so that it ceases to be random.
Yeah.
You know what I mean?
Yeah. That's quite contradictory.
But this is really something that's there on top of. I mean, engineers and computational linguists and people who work in the cognitive sciences as well are really on top of the importance of randomness in the speech signal. And most good models have, like based on what they call fuzzy categories and things like that, most good models have that accounted for in some way.
And to finish in a more general way, do you think artificial intelligence will play an important role in your field?
Yeah, it already does. And my field plays an important role in artificial intelligence. That's why it's so cool. What else, what's deeper, what's more human than language, right? I mean, artificial intelligence is really just a way to sort of externalize what goes on in your head, right? So instead of just going on in your head, we're externalizing this to a machine. Well, I mean, therefore data, taking linguistic data to work with in order to give it something to learn is makes it more sophisticated. There's not many more systems, or there aren't many systems more complex than language. So of course, if they can create computational models in artificial intelligence to learn language, they can pretty much teach it to learn anything, right? I mean, you could train it, and at the same time, it helps my field as well. We make models, for example, in cognitive linguistics and sort of phonology and different branches, phonetics as well. We use artificial intelligence to make predictions about how an ideal human learner might learn different categories. So for example, I can make a computational model, I can plug in all of the parameters, the acoustic parameters that a child might have access to, and then I can run that model, I can do a simulation with it, and it will give me results about the learning. So for example, they could say, no, the difference between an I and an E isn't big enough for somebody with a first language like Spanish to acoustically perceive, therefore they're not going to be able to learn that very well. So what I can do with those predictions, with the outcomes of those simulations, I can take that then and use observational data with young children learning their first language or people learning a second language, and I can compare the predictions of the model with the way children really learn, or the way a second language speaker really learns their second language, and then it's like a cycle. And then with that I say, oh, okay, the model couldn't predict this, the speaker could actually learn it. Okay, well then we're missing something in the model, right? We're missing something in the artificial intelligence, because the child was capable of learning it. The computer said that it wasn't, and they were able to learn it. Or the computer said that it was, they should be able to, but the child wasn't able to learn it. In that case, you might ask, well, does the child have a problem? Or, you know what I mean? So they're very complementary. And in fact, it's probably the most, I don't know if it's the biggest, but it's one of the areas.
No doubt.
at least in the United States where I'm from, it's one of the areas where that's having really the most success right now in linguistics, is computational linguistics. You know, because it's literally at the crossroads of you know, science and humanities. I mean, you've got something that's so beautiful as language, which can be studied as a humanity, you know, if we, you know, every culture, not every culture, but, you know, at least certain cultures use language, you know, for aesthetic purposes, poetry, literature. Look at some of the human things that you can express only with language. But at the same time, there's also that scientific element which everybody likes, right? I mean, which your generation, especially, that you grew up with, you know, new technologies constantly evolving and things like that, and you dominate them very well. You know, so it's a marriage between two great things. You know, you've got language, which is just, you know, sort of interesting in itself, but then you add the technological dimension and the mathematical dimension, and it sort of is at the crossroads of like so many different disciplines. So yeah, I think so.
Okay, thank you very much.
Cool, thank you. And